Okay, hello and welcome back. In this video, we're covering section 4.4. So we've been solving systems of linear equations via various methods, via substitution and elimination. So now with those in our pocket, let's solve some application problems. So some word problems involving these kind of processes in order to solve. So our first example, they're calling it solving problems involving general quantities. So let's read through and see how we can use a system of two equations in order to solve the question. So it says on a chart compiled from 1963 to 2015, Pink Floyd's album The Dark Side of the Moon spent more weeks on the Billboard 200 chart for top-selling albums than any other album in history. It was on the chart 351 more weeks than the second place album, Legend by Bob Marley and the Wailers. These are both really good albums if you've never listened to either one. But notice here we get our first statement that we can probably build a little equation out of. This was on the chart 531 weeks more than Legend. Then it says if they were on the charts for a total of 1,303 weeks, so there's a total amount. How many weeks did each of them spend on the Billboard 200 chart? So I see a couple things. Whenever you see like some total amount, that's usually something plus something will equal the total. That's usually a good candidate for an equation. And then we also have this relationship between them. One was 531 more than the other. So first, let's just declare our variables. Let's define what they are and try to build two equations out of this little paragraph. So I'm going to say let x equal the number of weeks that Dark Side of the Moon was on the chart. I'll just say was on the chart. So then y will be the number of weeks that Legend was on the chart. All right, so let's take these two statements. One is Dark Side was on the chart 531 more weeks than Legend. So I can say the number of weeks that Dark Side was on the chart, which is x, is equal to the number of weeks that Legend was on the chart plus 531. So one is 531 more than the other. And then it says they were on the charts for a total of 1,303 weeks. So if we took whatever x is and added it to whatever y is, that should add up to 1,303. So we have a system of two equations with two unknowns, and we want to solve. So we can choose like substitution method, elimination. I see the first equation is already solved for x. So I'm going to use the substitution method. I'm just going to substitute this whole expression for x in our second equation. So let's do that. We could also do elimination if we wanted to, but I'm going to go for substitution. So I'm going to replace x in the second equation with that expression y plus 531, then plus our second y should equal 1,303. So I have two y's now. Y plus y will give me 2y. So 2y plus 531 equals 1,303. Then let's subtract the 531 from both sides. So I'll be left with 2y on the left side. 1,303 minus 531 is 772. Then divide both sides by 2. Let me just double check that previous subtraction. 1303 minus 531. Yeah, 772. Then divide that by 2. 772 divided by 2 should give us 386. So we have one part of our solution. Now let's go and plug this into one of our previous equations. And let's plug it into the one that's already solved for x. That will make things very nice for us. So x equals y plus 531. So let's substitute in 386 for y. X equals 386 plus 531. Then adding those together, x equals 917. So there's our second solution. We can express this as a coordinate point, but let's answer it in terms of the context of the problem. So we can say x was dark side of the moon. So I'll say dark side, just abbreviate, was on the charts for 917 weeks. And then y was legend. Legend was on for 386 weeks. Insert weeks. So since it's a word problem in context, I usually want to give my answer in context of what these variables were describing. So we had to first translate from the word problem into equations, and oftentimes that's the most challenging part. So I'm always looking through the question for something that can be expressed in terms of numbers. A total is usually a good one to use, and then a lot of times something will be described in relation to something else. You see like 531 more than the other one. So it takes a little bit of practice, but if you can start to pick those out of a word problem, you can get into equation mode. And then it's helpful to start out by first identifying what the variables are going to describe. So pick something for x to describe, pick something for y to describe. And it's helpful to write it out, and that can help you kind of formulate what these equations should look like. All right, let's look at another problem involving some kind of geometric situation. So it says a builder installed a rectangular window in a new house and needs 182 inches of trim to go around it on the inside of the house. So we have some rectangular window. And they give us some like total amount of material to go around. So that should make you think about the perimeter of this object. So the perimeter of a rectangle is 2 of the lengths plus 2 of the widths. So let's just keep that in mind. Oops. Then it says, find the dimensions of the window if the width is 23 inches less than the length. So let's call this the length, the long side, and the width, they're saying, is 23 inches less than the length. So I can say W equals whatever the length is minus 23. So that does give us one of our equations, and then we know we have 182 inches all the way around. That'll be the perimeter. So I can say 2 of the lengths plus 2 of the widths will equal that total amount of 182. And then we have this second statement that the width is 23 inches less than the length, or the length minus 23. So now we have a system of two equations with two variables, and let's solve the system. And just like last time, we have one that's already solved for a variable, so I'm going to use substitution here. So in the first equation, let's substitute for w. I'll use some parentheses, and I'm going to plug in L minus 23. And this will equal 182. So now let's solve for L. So I'll distribute that 2 through. So 2L plus 2L minus 46, multiplying both of those by 2, equals 182. So let's add those two L's together. I'll have 4 of them. And then let's add the 46 over to the other side. So 182 plus 46 is 228. And then divide both sides by 4. I get that L equals 57. So now let's take that L and substitute in, let's use that second equation that's already solved for W. So I can say W equals L minus 23. We're saying L is 57, so W will equal 57 minus 23, which is 34. So our length is 57, our width is 34 inches. So let's answer the question in that context. Length is 57 inches, width is 34. So again, we have some word problem. This one involved some kind of geometric object. So we did have to remember the formula for perimeter. But it was kind of like the last one. We're given some total amount. The total is usually a good thing for an equation. And then they described one of our variables in terms of the other. That's how we got our second equation. And then just had to solve it from there, like a system of two equations. All right, let's look at another one involving some kind of cost question. So it says Ari buys two mezzanine, I think that's how you say that word, tickets to a Broadway play and 4 tickets to the top of the Empire State Building for $352. I see that like total kind of statement again. So let me see this again. There's 2 Broadway play tickets and 4 tickets to the Empire State Building for a total of $352. Then Lloyd spends $609, maybe I'll do this in a different color, $609 on 4 tickets to the play and 3 tickets to the Empire State Building. And we want to find the cost of each ticket. So let's first declare what our variables will be. I'm going to say X will be the cost of a Broadway ticket. And Y will be the cost of the Empire State Building ticket. So let's try to use these two statements to build two equations. The first one says buying 2 tickets to the play and 4 tickets to the Empire State Building costs $352. So I can imagine I have 2 of the Broadway tickets plus 4 of the Empire State Building tickets, and the total cost is 352. Then that second statement said there were 4 of the play tickets and 3 of the Empire State Building tickets cost $609. So now we have a system of 2 equations and 2 variables. Now, let's see, if I multiplied this first equation by -2, it would give me a -4x, and then I can solve it via elimination. So let's take that route. I'm going to multiply the top equation by -2. So that will give me -4x minus 8y, and then 352 times -2 should give us -704. And the second equation we're keeping the same. We have positive 4x plus 3y equals 609. So now let's add these together. The x's will cancel, which is what we want. That's the elimination method. -4x plus 4x is 0x. And then -8y plus 3y is -5y. And then -704 plus 609 should give us -95. Then dividing both sides by -5, we get that y equals positive 19. So let's take this y value and plug it into one of our original equations. I'll just take that first one. We had 2x plus 4y equals 352. So let's plug in 19 for y. 2x plus 4 times 19 equals 352. 19 times 4 is 76. So 2x plus 76 equals 352. Let's subtract the 76 over to the other side. So 2x will equal 276. Then dividing both sides by 2, x will equal 138. So let's answer in terms of the context of our problem. The Broadway ticket was $138 per ticket, and the Empire State Building is $19 per ticket. That was our Y. So we basically had like 2 total statements for this one. Some number of Broadway tickets plus some number of Empire State Building tickets is some cost, and then some other number of Broadway tickets plus some other number of Empire State tickets gave us some other cost. So just with that kind of limited information, we're able to solve how much that each ticket costs using this method of systems of equations. So it can become very useful if you're trying to figure something out with limited information. All right, let's look at, if you remember, we did some mixture problems previously with one when we were solving equations in context in a previous video. So let's see it in terms of systems of 2 equations. So it says a pharmacist needs to make 200 milliliters of a 10% hydrogen peroxide solution. She will make it from some 8% hydrogen peroxide solution and some 16% hydrogen peroxide solution that are in the storeroom. So we need to find out how much of the 8% solution and how much of the 16% solution. So that's a good candidate for our 2 variables. If you're ever unsure what they should be, think about what the question is asking you for. We can call X however many milliliters of the 8% solution. And we'll call Y however many milliliters of the 16% solution. So let's think about what totals we have. We know we have a total of 200 milliliters. So that can give us one equation, because X and Y are both just the total volume, the total milliliters amount. So X plus Y should equal 200. And then we know the total solution needs to be 10% hydrogen peroxide. So let's think about just like pure hydrogen peroxide. We know X is milliliters of the 8% solution. So if we find 8% of X, or if we multiply 0.08 times X, that will give us the milliliters of hydrogen peroxide. And similarly for Y, if we multiply Y by 16% or 0.16, that'll give us the milliliters of pure hydrogen peroxide. And then we had our total amount was 200 milliliters, and that is 10% hydrogen peroxide. So that would be multiplied by 0.10 to find 10%. So we have two statements here. One is just for total milliliters, and then one is for the total hydrogen peroxide. These can be a little tricky to set up, but now we have our system of two equations with two variables. So first, I kind of want to get rid of these decimals. So I'm going to multiply the second equation by 100. That will effectively move the decimal places over 2 spaces for each of those. So let's rewrite this with those decimals cleared. So our first equation stays the same. I have X plus Y equals 200. Now with the second equation, we multiplied each term by 100 to move the decimal place over 2 spaces. So this becomes 8x plus 16y. And then this 0.10 got multiplied by 100, so it becomes a 10. So 10 times 200 is 2,000. So a little bit nicer system to work with. So we can solve this either via substitution or elimination. I will choose, we can do either way. I'll try elimination. If I multiply this top equation by -8, we'll be able to cancel and eliminate the x variable. So the first equation would become -8x minus 8y, and 200 times -8 will give us -1600. Then our second equation is unchanged now, 8x plus 16y equals 2000. So let's add these two equations together. The x's are eliminated, which is what we want. -8x plus 8x is 0x. Then -8y plus 16y, that's like 16y minus 8y. We'll have 8y left over. And then 2000 minus 1600 is 400. So dividing both sides by 8, I get that y is equal to 50. So there's our first piece. Now let's take this and plug it in to, I'll just pick that first equation. We had x plus y is equal to 200. So I'm plugging in 50 for y. So x plus 50 equals 200. Subtract 50 over, and x equals 150. So let's answer in terms of the context of our problem. We will have 150 milliliters of the 8% solution. That's what x represented. And then 50 milliliters of the 16% solution. That will mix to create our desired result. So for me, these mixture problems are a little bit more tricky to set up, to think about. So if you set up two equations, one where you have the total milliliters, and then the other equation, which is the total like pure substance that we're taking, that is like some percent of the mixture, because it'll be like water mixed with 8% hydrogen peroxide. That's our first case. So if we have x being the total milliliters, well, 8% of whatever that is our pure hydrogen peroxide. So that's what we did for this second equation. 8% of however much x is plus 16% of however much y is will be 10% of our total milliliters, because it was 200 milliliters of a 10% solution. So for me, that's the tricky part. But then once you have the equations, the rest is just following our process of solving a system. And you could have done this pretty nicely also with substitution as well. If we just solve this first equation for x or y and substitute it in, so we could get there multiple ways. Okay, our last example is a distance, rate, and time problem. Let's take a look. So it says two cars leave Kearney, not sure if that's how it's pronounced, Nebraska. One driving east and the other heading west. The eastbound car travels 4 miles per hour faster than the westbound car. So I see some relation between them. And after 2.5 hours, they are 330 miles apart. There's like a total statement there. Find the speed of each car. So that tells me that x should be the speed of one car, y should be the speed of the other car. So let me state that. I'm going to say let x equal the speed of the westbound car. And I'll say y equals the speed of the eastbound car. All right, and just to draw out the situation, we have some starting point. One car drives west, so it's over here. The other car drives east, so it's over here. And the total distance between them after 2.5 hours is 330 miles. So we can say these two separate distances should add up to 330 miles. And distance, we can describe that as speed times time. Like if I'm driving 30 miles per hour and I drive for 2 hours, I would take the 30 and multiply by 2. That kind of idea. So if x is the speed of the westbound car and it traveled for 2.5 hours, I can describe this distance as 2.5 times x. And if y is the speed of the eastbound car, I can describe this distance as 2.5 times y. And they should add up to 330. So that can be our first equation. We can say 2.5x plus 2.5y equals 330. And then we said that the eastbound car travels 4 miles per hour faster than the westbound car. The speed of the eastbound car is y, so this should be however fast the westbound car is traveling plus 4 more miles per hour. So there's our second equation. It's already solved for y, so let's substitute that into the first equation and then solve for x. So I have 2.5x plus 2.5, instead of y, I'll substitute in x plus 4, and this is equal to 330. Now let's solve for x. I'll get rid of the decimals. We can multiply everything by 10, and that will move the decimal place over one spot. So that would turn this into 25x plus 25 times x plus 4. And the 330 needs to be multiplied by 10 as well, so it picks up another 0, 3,300. All right, let's solve for x, so let's distribute this 25 through the parentheses. So I get 25x plus another 25x plus 100 equals 3,300. We have two 25x's, so they'll combine to be 50x. And then if we subtract that 100 over, we'll get 3,200. Then let's divide both sides by 50. So x equals 64. And then we said for our second equation, y equals x plus 4. So this one's pretty nice. Y will equal x plus 4, which is 64 plus 4, or 68 miles per hour. So let's give our solution in context of the problem. We said x is the speed of the westbound car. So I'll say the westbound car is traveling at 64 miles per hour. And the eastbound car, which is y, is traveling at 68 miles per hour. 4 miles per hour faster. So these can be a little bit tricky too, but a lot of times they'll give you some total distance after a given amount of time. And if we're looking for speed, just keep this fact in mind. Distance is speed times time. We can use that. But again, once we have our system set up, the rest we're just following the procedures of solving a system of two equations. And this time we did substitution. All right, that's it for this video. So we solved some problems with general quantities. We saw a geometric example, a problem involving cost. Saw a mixture problem, and we finished off with that distance, rate, and time problem. But all of them we were able to solve using our methods of solving a system of two equations, either by substitution or elimination. Okay, that's it for this video, and I'll see you next time.